So in this problem, we have B and D being points of tangency, and we want to determine the length of segment DC. So we have to remember, points of tangency means that's a place where the segment intersects the circle's radius and makes a right angle. So they are perpendicular to each other. So let's draw those perpendiculars, the right angles, in the two places of tangency. Then let's see what else we know about our diagram. We see that AB is 5, and that's a radius for our circle. We have 3 radii represented in the circle, AB, AE, and AD, so all of those measurements are also 5. Then if we think about it, we know that C to E is 8, so these two segments here form a third segment CA, which would have a length of 13. And we want to determine the length of our segment DC, which is here. So let's look at our picture again. So we've got this right triangle, right, where we know that AD, that side length is 5. We said AC is a length of 13. We're looking for a length CD. Well, when we have a right triangle and we know 2 of the 3 sides, we could use Pythagorean theorem to help us. Remember, Pythagorean theorem says the sum of the 2 legs squared is equal to the hypotenuse squared. And we know our hypotenuse is AC, 13, because it's across from the right angle here. The 2 legs are what form the right angle, so AD and CD. So the sum of the 2 legs squared is equal to the hypotenuse squared. So by working out your Pythagorean theorem, we're going to solve for that missing piece. Well, you know if we squared 5, it's at 25, and 13 we get 169. So at this point we'd have to subtract 25 from each side of our equation. Then to undo something that's square, we must take the square root. And we know the square root of something squared is the absolute value, and 144 is a perfect square. It has a value of 12. Now remember, whenever you take the square root of something squared, you do get the absolute value that measures the distance from 0, which means you're going 12 units to the left of 0, which would be negative 12, and 12 units to the right of 0, which would be 12. Because this is a length, you cannot have it be a negative measurement, so we have to say that 12 is the side length representing CD, so 12 units. Maybe some of you also noticed that this was a Pythagorean triple, 5, 12, 13, and you could have answered that question a little bit quicker back here on step 1, as long as you said, hey, it's a triple, 5, 12, 13, you're good to go. Otherwise, you can always default back to your Pythagorean theorem and solve for any missing side length for the right triangle as long as you know 2.